Welcome to the School of Chemical and Process Engineering here at the University of Leeds. My name is Esther and I'm an integrated master's student studying chemical engineering. The school is located on the north corner of the campus beside the School of Civil Engineering and is your home if you're a student in, as the name suggests, chemical engineering, but also students studying areas such as materials science. We also have the Bragg Centre for Materials Research, which is just down the road, but more on that later. Practical skills are important in both chemical engineering and materials science, so you'll spend a lot of time in the labs developing your practical skills. Follow me and let's take a look at one of the labs.
Hi, I'm Kent, a second-year undergraduate student studying chemical engineering, and welcome to the Undergraduate Teaching Lab. As chemical engineering students, this lab will be your hands-on environment for learning how to operate in industrial standard equipment, scaled down just for teaching purposes. And these tools will serve as the foundation for your practical assignments, helping to understand key concepts such as heat transfer, reaction kinetics, and more. Beyond mastering technical skills, you also gain a deep appreciation for lab safety protocols, extending far beyond our basic PPE that will be greatly emphasized during your second year. While the equipment here are more compact, it mirrors the functionality of the larger industrial systems you encounter during site visits in your first year. This lab will give you the fundamental experience to prepare you for those real-world applications, and some of the specialist equipment you'll get hands-on experience within your first year includes these batch and continuous reactors, heat exchangers, absorption columns, and cooling towers. And recently, the school have also invested in some new equipment such as process control and instrumentation units and fluid flow devices. Therefore, you get exposure to the wide range of process equipment used in the chemical engineering sector by undertaking an interesting experiment that will help you to reinforce in theoretical concepts. Moving on.
2. The Specimen Preparation and Microscopy Facility. This lab offers advanced specimen preparation, advanced light microscopy together with electron microscopy. Both undergraduate and master's students gain expertise here, developing practical skills in materials and wider engineering topics. Theory is just as important as practical skills, and this is taught in a mixture of lecture theatres for bigger classes, this school has 3, and seminar rooms for smaller group projects. These lecture theatres are set up with the latest audio-visual technology, presentation equipment and lecture capture software, ensuring you're equipped with the knowledge you need for your labs and beyond. Shall we grab a coffee? This is the Fuse Cafe, located directly outside Lecture Theatre B and C, and is the perfect place to grab a drink or snack between classes. And there's plenty of seating for studying or collaborating. But if you need somewhere quieter away from the hustle and bustle to knuckle down with that assignment you've been procrastinating for longer than you should have, there's 4 libraries dotted around campus. Speaking of assignments, follow me. This is the 24-hour computer cluster. Sometimes we have classes here, but any other time it is accessible, as the name suggests, 24 hours a day, to come in and complete assignments away from the distractions at home or access any of the specialist software with apps anywhere. My favourite piece of software is definitely the virtual chemical processing plant. This software lets you walk around a 3D chemical processing plant and simulate real-world situations that aren't possible to replicate in the real world, such as a fire. But it lets us build up the skills and knowledge to help deal with similar, but also less traumatic situations if they were to occur in the real world. Speaking of the real world, we do real-world research, which has an impact globally. Let's check out.
This £3 million lab was funded by the Research Council and is our newest research facility in the school. As a zero-emission, clean energy source, nuclear will be a part of the sustainable energy mix alongside wind, solar, wave and geothermal going forward, not just in the UK, but worldwide as well. This lab answers this growing need in industry. Here you get a chance to conduct your own experimental investigations in nuclear engineering using the latest state-of-the-art equipment. It provides a real system environment where you can study multi-phase flows in water, acidic systems, and high-temperature molten salt systems. You'll use real materials, aqueous acids with solids, in industrial-scale pipes with flanges, joints, and bends that are comparable to real-world plants. This lab is equipped with a pilot-scale water loop, a pilot-scale molten salt loop, and a bank of high-precision instruments for measuring a wide range of fluid flow properties. Not only that, but both rigs can be reconfigured to include specialist instrumentation for fluid flow measurements and bespoke equipment for experiments. This is a collaborative space where you can work on your own research projects and where researchers from industry come and develop their latest innovations alongside you. It's the only one of its kind in the country, meaning it's the UK's leading experimental nuclear institution for multi-phase fluid flows. But this isn't the only high-tech research lab we have on campus.
Welcome to the Bragg Centre for Materials Research based here at the University of Leeds. This is an interdisciplinary research facility dedicated to discovering, creating and designing new materials. Here we have our classes, laboratory sessions and project research using these world-leading facilities. This room houses the Tescan Amber X Focus Ion Beam Scanning Electron Microscope. This uses electrons to image materials from the atomic scale to the macro scale and is an instrument I will personally be using as part of a project this year. I will be reverse engineering some advanced chemical products such as wound healing cream. For this, I'm using microscopy to measure the size and distribution of the antibacterial silver particles in the cream, and this will help me make the link to the performance of the cream. This is just one of the examples how instruments like this can be used. Materials science and engineering is at the forefront of global challenges such as the upcoming energy transition. Understanding how a material works by linking structure to performance is key to the development of new products and processes. Shall we explore the X-ray diffraction facility? X-ray diffraction is a Nobel Prize winning technique that was discovered here in Leeds. These instruments can measure the crystal structure of a material. We learn the importance of crystal type and size in shaping the properties of a material in our first and second year lectures. Practical laboratories then teach us how to do the analysis so we can use the techniques in our research projects. Finally, this facility measures the surface chemistry of a material which can govern how it may react in different environments. This is another advanced research technique that we can use to understand the performance of a material and feed into the design of new products. This was just a quick look at some of the spaces here at the School of Chemical and Process Engineering, but there's so much more for you to discover, so we hope to see you soon.